All right, so previously we talked about a one-tailed test. So this is going to be a two-tailed test. Okay, so let's see, what do we know? We have a random sample of 12 workers, so n is 12, that's our sample size. And we know that they are normally distributed, okay? And what else? The population mean, the claim is that it is 45 minutes. So the null hypothesis is that the mean is 45 minutes. So another thing I should add here is if your sample size is less than 30 and it's normally distributed, so the samples are taken from a normally distributed source, normally distributed population, and we do not know the variance, right? So population variance is unknown. Then we have enough reason to use the t distribution. So this is a good reason to use the t distribution. Okay, anyway, what is our our alternate hypothesis? So our alternate hypothesis here is that the mean is not 45. Right, because it says here, investigate the claim that the population mean is 45. So the statement that opposes that is it is not 45. So if it's not 45, then our test statistic is going to lie in one of these rejection regions. So it's going to be, on one of these outlier regions right here. So if our alternate hypothesis, if our null hypothesis is rejected, then our test statistic will be in one of these regions. And it says use a 5% significance level. So the 5% actually represents the total rejection region divided by the total region. So this bit here plus this bit must be 5%. So if we think about it, this should be 2.5% and this guy should be 2.5%. Okay, so again, in order to actually make a conclusion, we need two things. We need the critical values. So we need this, we'll call this TC1, and we need this other critical value, which I call TC2. And as you can probably see, TC2 is just a negative TC1 because it is symmetric, right? And we also need to know where the test statistic is going to be. And the test statistic is going to be x bar minus mu over s over square root of n. And we can work out what x bar is. Just take the mean of these 12 samples here. So x bar is going to be 44.1. Okay, and then the unbiased estimator of the standard deviation, if you work that out correctly, you should get 2.86. So again, these are in 3 significant figures. And now we're going to put them into our formula for the test statistic and work out what that is. Use the unrounded values again. And if you do that correctly, you should get negative 1.05. Okay. Now, how do I work out TC1 and TC2? So if you think about it, right, if you try to draw this out like this, we know this area is actually 95%. Hang on. This area is 95%. So if I want to work out what TC2 is, this entire area is going to be 2.5% plus 95%, right? So that will give me 97.5%. So our percentile P is going to be 0.975. There we go. Alternatively, what you could do is you could work out P like this. You take 1 minus our significance level divided by 2. So in that case, it will be 0.05 divided by 2. Wait, hang on. 5%. Oh yeah, there we go. hang on, 5%, 25, 975. Yep, that's right. So there. This is another way of doing it. Okay, and then the what do you call this? Degree of freedom is going to be 12 minus 1, which is 11. So now we're going to look at our Lisa formula here. We have 11 and we have 0.975. So that tells us that our critical value TC2 must be 2.201. Okay, which means TC1 must be negative 2.201. All right, so let's redraw that real quick. This guy here is 0. This guy is negative 2.201. This guy is 2.201. And that's the rejection region. Now, where is our T? Our T is actually negative 1.05, which is somewhere here. Negative 1.05. And then, as you can see, it is not in any of the rejection regions. Therefore, since T is... hang on, let me just move this around. Since T is less than TC2 and greater than TC1, we do not have sufficient evidence to reject the null hypothesis. And done.